Hello everyone. In this presentation, I will be discussing my vulnerability analyst enumeration of the Kioptrix Level 1 virtual machine. Using Kali Linux, I perform host discovery, service enumeration, OS detection, and vulnerability scanning to identify weaknesses within the target system. This presentation explains the steps I used, the scan results I found, and how those findings supported my flaws hypothesis about possible attacks path on the system. Lab setup. For this lab, I use Kali Linux as the attacker machine and the Kioptrix Level 1 as the target machine. Both virtual machines were connected through a host-only adapter in the virtual box, so they could communicate on the same private network. This setup created a safe lab environment for testing. After confirming the network settings, I identified the target on the 192.168.56.0/24 subnet and confirmed that the Kioptrix target IP address was 192.168.56.102. After setting up the lab environment, I begin with enumeration and footprinting. I use the ARP scan to identify activity hosts on the local network and then use the Nmap with the ping scan options to verify host discovery. This setup was important because it confirmed that the target system was online before running deeper scans. Enumerations help build an understanding of the network and makes it easy to identify likely attacks path based on researchable systems and services. Next, I ran the main NetMap scan using the sync scan and service version detection against the Kioptrix target. The scan identified 6 open ports. Port 22 was running Open SSH 2.9p2. Port 80 was running Apache 1.3.20. Port 111 was running RPC bind. Port 139 was running Submaria. Port 443 was running, and HTTPS with Apache Mode SSI and OpenSSL, and port 32768 was running in RPC status service. These results show that the system have several exposed and outdated services, which increased the overall attack surface and made the target a good candidate for vulnerability analysts. Additional Nmap command OS detection. For the first additional Nmap command, I use OS detection with nmap-o-pn. This scan suggests that the target was running on Linux 2.4.x operating system, which is very old. The scan also showed that the host was one network hop away. This result was important because it provided more context about the target and supported the idea that the system was running outdated software. An older operating system often means a greater chance of legacy vulnerabilities and weakness configurations. For the second additional Nmap command, I use nmap-sc-sv to run default script and gather deeper service information. This scan provided more detail about the service running on the system, especially the HTTPS and SMB related services. It showed SSL v2 support, weak chipper suits, certificate details, and the net BIOS name Kioptrix. These results gave stronger evidence that the target was running insecure legacy services and weak cryptograph support, which increased the likelihood of exposures of flaws. Floyd hypothesis methodology is the process of using scan result services, versions, and observed system details to form a logical guess about likely weakness in a target system. It starts by identifying open ports, exposed services, and outdated versions. Those findings are then compared to known vulnerability patterns and risky legacy technologies. In this lab, the methodology showed that Kioptrix 1 was running multiple outdated services, especially Subarta Apache and OpenSSL and Mode SSI. Based on these results, my Floyd hypothesis was that one of these legacy services could likely be exposed against unauthorized access and potentially root privileges. Vulnerability map. This slide shows the vulnerability map I created from the scan results. I mapped each open port to its associated service, identified the version information, and listed the possible risks connected to each one. This helped organize the finding and made it easier to determine which service represented the highest risk. The most important entry were Somalia on port 139 and Apache with OSSL support on port 80 and 443. These services stood out because they are older technologies with a history of vulnerabilities and insecurity configurations. Root causes and conclusion. In conclusion, the Kioptrix Level 1 scan results showed that the system was exposing several outdated and insecure services, including SSH, Apache, RPC bind, Somali, HTTPS, and RPC status. These findings showed that the target had a large attack surface and multiple possibility entrance points. The most serious weakness were the legacy Somali service on port 139 and the old Apache Mode SSI and Open SSL service on port